Sizing eaves gutter. First place we're going to start is by opening the unit. There we are there, we opened it up. The next thing we're going to do is open the actual assessment task, which is this one here. And we've already got it open, so we won't reopen it. You would click OK. I've already done it, I've got it here from earlier. So what I'll do is I'll bring it across so you can see what it is. So this is the project we've got, this particular house. So we're going to work on this house and come up with an acceptable solution for the number of downpipes, for the catchment that it has, and the size of the downpipes that we're going to use in order for it to work. We're going to look here at the roof pitch, because that's important, and the overall dimensions of the house. So we'll come back to those in a moment. First thing we've got to do is go to table 334, which is where we're going to find the ARI that we're to use. So if we go to additional resources, go down to stormwater code, open that up, get rid of the yellow ribbon, hit Control F, which will give us a find function down the bottom. And we're going to delete this here, and we're after table 334, so 3.3.4. And here's the table we want. Eaves gutter external. In Australia, the ARI that we're to use is equal to or greater than 20. If it was box gutter, it would be different. It would be equal to or greater than 100. But for us, it's equal to or greater than 20. So we're going to, first thing we're going to do is put that in our answer. So we'll go to symbols, go to equal to or greater than 20. The next thing we're going to do is we're going to determine the rainfall intensity for the area. So we need to go see guideline appendix D, and it's actually E, but we'll go and have a quick look there. So first thing we're going to do is type in appendix space E. Now we're down in D already, so we're going to get E. Now we're looking for Hobart in Tasmania. So that's ACT and New South Wales. Keep going down. Queensland here. Tasmania, that's what we're after. And Hobart. So if we go across here, we'll see Hobart has a 20-year ARI of 86 millimeters per hour. So we're going to head back into our assessment, and it is 86 millimeters per hour. So that is quite an important figure for us, which we will come back to. Now we need to obtain the general dimensions of the roof. So let's get back up and have a look. First thing I'm going to do is break this up into a rectangle and a square. So the square, if I run a line directly from the bottom of the valley there straight across to the 12, that will give me a square here 6 meters by 6 meters, and a rectangle 6 meters by 14 meters. So what we need to do is write it up now. So 14 times 6 equals, and 6 times, 6 equals, space equals. Right, so if we get our calculator and we quickly work out. I'll move this back across here so we can read it. So 6 by 6 is 6 times 6 equals 36 square meters, and 14, not 147, 14 times 6 equals 84. So 84 is here, like so. Then we now have to work out what the total is. And 84 plus 36 equals 120 meters squared. So it'll be 120 meters squared. So go to the symbol, head down here, squared. Okay, so that's our catchment. Calculate the catchment areas A and H. So in order to do this, we've got to work out our factor. So what we've got at the moment is the catchment area in plan view. We don't have the catchment area yet in total because we have to allow for the slopes on the roof in order to get that. So in order to work that out, we've got to work out what the factor is. So the factor is quite an important element. So let's work out what that is. We've got to go to clause 3.4 for that. So if I just go back over here and 3.4. So we're going back to find clause 3.4. 3.4 is catchment area. So there it is there, catchment area. Right, in order to work out the factor, we need to work our way through till we get to this table here. So it's the catchment area multiplier for ratios. Now, if we go back and have a quick look, we need this figure here. The degrees, how many degrees the pitch of the roof is. So we can see here it's 32 degrees. So in order to work out the factor, we need to work it out on a 32 degree pitch roof. So if we go back here and we go down till we get to 32, we'll see it's got a factor of 1.31. So that's very important. So we'll go and put that in now, 1.31. 1.31. That's the factor. Now what we need to do is multiply our square meterage by the factor to get our true catchment area. So 1.31. And so that will equal, if we bring our calculator back, I've just got to grab it from over here. And there it is there. It is 120 multiplied by 1.31 equals 157.2 equals 157.2, and that is meters squared. And that is our total catchment. Total catch, MENT. Alright, that's our total catchment. So the key figure there is 157. So we probably need to highlight that. The other one we need to highlight is this one here. Right, and the next one we need to highlight, the figures that we need in order to get our answers for later, is that one there. So what we've got to do now is we've got the cross, we know it's got 4, 1:500. Then we've got 6,490 is the cross-sectional area. What we're talking about there is the height of the back of the gutter, plus the width across, the actual area that the water encompasses in the gutter. So it's very important that we understand that it's where the actual water sits in the gutter. So on a cross-sectional basis of the profile of the gutter, we would end up with 6,490 millimeters squared, and we would get this from the manufacturer's data sheet on the type and profile of gutter. So that's where we find that. So in order to work this out, we've got a gutter that has a gradient of 1:500 and steeper, so we need to look at figure 354A. So let's go and have a look at 354A. So 3, 4, 3, 4, 3, 3, 5, 4. That's this one here. 354, size of Eaves gutters for gradients for 1:500 and steeper. Be careful. There is another chart on the next page which looks very similar, but as you can see here, 354B is the size of Eaves gutters for gradients flatter than 1:500. Alright, and the figures are different, so be very careful. Alright, so but the one we need is this one here. Size of Eaves gutters for gradients up to 1:500 and steeper. So if we look at this one here, we are going to use the effective cross-sectional area here in order, and we're going to use the rainfall intensity in order to find out how many square meters of roof we can put as a maximum per downpipe. So if we look here, the cross-sectional area is 6,490 millimeters. If we go straight up here between 80 and 90, now 80, if we're probably saying why 80, 80 and 90, 86 halfway was how many millimeters per hour we did in step 2. So we worked out that there was 86 millimeters per hour was the ARI for this particular area. This was the profile of the gutter, and this will now give us, if we go straight across here, it's approximately 75. So it's 75 square meters of roof area is the maximum catchment per downpipe that we're allowed. So what we need to do now is go and have a quick look at what that is. So 75 is what we've got, so we'll head back into our area, and it will be 75 meters squared is our area. And what we need to do now is work out, that's the maximum area that can go to a downpipe. So what we need to do now is divide our catchment area, 157.2. So we'll do it here, 157.2 divided by 75 equals, and we'll work that out with our calculator, 157.2 divided by 75 gives us an answer of 2.096. So that is, we need a minimum of 2.096 downpipes for this particular roof. Now, as you can see, we're just over 2. In a case like this, we would always roll up to 3 downpipes, and for the catchment, so we're going to be 3 downpipes is the answer. There is the minimum that we're going to have, and that's how we do it. We always round up. So we round the total catchment area, divide it by the catchment, maximum catchment per downpipe, and we end up with 2.096. So we have to round it up, so that becomes 3 downpipes. So now we know there are 3 downpipes. We need to draw on the drawing where all the high points and low points are, but we don't quite have enough information yet. What we've got to do, we'll come back to that. So what we have to do is we need to review all this, but we need to, before we do that, we need to divide here how many downpipes there are. So it's 3 downpipes, so that will equate to there. The catchment per downpipe is going to be 157.2 divided by 3. And what we're trying to do now is work out what the actual catchment is going to be for the 3 downpipes. So if we clear this and then we go 157.2 divided by 3 equals, it means that there is a total of 52.4 meters squared per downpipe is the catchment now, which we can see is lower, right? It's lower than the total, which is 75, which is what we need. We need a buffer. So that's what we're looking for. So we divide that roof into 3, and that's what we get. Now we'll come back and have a look at that in a minute. Before we go any further, we've got to do the next bit, which is the catchment area for each subcatchment less or equal to the maximum per downpipe? Yeah. Yes, it is. So that's very important that we get that answer, because that makes it all viable. So now we've got to determine the number of downpipes. Now we're using rectangular downpipes, so we've got to use table 352 based on the gradient and size of Eaves gutter that we're using. So let's go and have a quick look there. So it's 352, 352. 352. 3.5.2. 352. All right, so there we are there. Okay, table 352. Eaves gutter, required size of vertical downpipes. So if we go down here, our cross-sectional area, we're looking at 1:500 or steeper, so the gradient that we have. Then we're going to look here at the size. So 6400, it's greater than that, but it's less than 66. So 6490 falls in. So we've got to use 66 as our guide. So we go across, and it's 75 by 70 rectangular downpipe that we are able to use. So 75 by 70. So let's get back into there. 75 by 70. 75 times 70. Okay, there we have it, guys. The only thing we've got to do now is complete the drawing. So that's back to step 9. So when you get back to step 9, there's our drawing. We need to break this drawing up into the areas that we need in order for this to work. So the way we're going to do that, I've done it previously before. We've got to break the roof down into areas. You'd look at your valley as a point, a central point to work both ways from, in this case. And I've already got if you go into the My Learning area and pull up Eaves Gutter, here's a very good example on how to break that particular roof up. You'll see there all the figures are there, and there you go. There's the breakdown of the roof. We've got 53.5 square meters in this section here. We've got a high point on the valley, come back around, and then we've got another 53 from the valley here back around to here, so that's 53.6. And we've got this last one of 51.5. So they're approximately about right. Remember, our maximum is 75 meters per downpipe, but we want to be somewhere around that 54 mark. 52.4 in order to get the maximum equal flow out of each downpipe. And there you have it, guys. That's how we do it.